Hello, my name is James Rule, and I am the current Vice President of the University of Kentucky Energy Club. And today we are going to show you a little bit about the projects that we have worked on in the past, and sort of go through the building process and how they work, and what we did. The first project we have to show is from the 2018-2019 school year. It was the first project we did because that was when our club was founded. And it is what we call the power bike, or electric bike, something along those lines. So basically, we had a bicycle, and we put together some stickers, some stands, just made it look nice. And then once we had that, we made an electric circuit, and we put that inside of a plastic box. So how it works is, when the bike is pedaled, it turns an electric motor, which feeds power into here and charges two 12-volt batteries, which are wired in parallel. Then we have a fuse, a bridge rectifier to convert AC to DC, because we want to use this to charge things that plug into USB ports. A DC-DC inverter, we have a Schottky diode, a resistor, and an overcharge protection board. And that's all the different parts that fit in here. Basically, once the batteries are charged by the bike, then they feed out into one of these little USB port things, and we can plug in phone chargers. We have here, we also have a couple other little devices that plug in there, new fun things that we would like to use during tabling or something like that. It was a very exciting building process because we were learning a lot as a club while we did that, and it was a really fun project to work on and to be involved in. And we would like to thank our sponsors for this project, Cummins, GE, the Center for Applied Energy Research, Spores, Dynetics, and the University of Kentucky College of Engineering. Thank you for supporting us in this project and helping us to make it possible. So when we were building this project, we were working on it, I think, a couple times a month in the evenings, and there would be a big group of people getting together. We had pizza, and we just worked in different groups, helped to figure out what needed to be done and address the problems and put it all together. And later on, that helped inspire me to join the executive board. I really enjoyed being part of the club and working on things like this. And so I was the education director for a while. And then when it came time for the next election cycle, I decided to run for project director because I knew so much about projects like this. I'd worked on it a lot, and I'd been able to gain a lot of experience that helped me moving forward with more work in the Energy Club and beyond. And so now I'm going to go back through the different parts of the bike. So this is a bicycle. Yeah, I think probably everyone knows what a bicycle does. So now what happens is you turn this pedal here, and it's going to feed into an electric motor, which generates AC current, which is basically used to charge a couple 12-volt batteries in there in parallel. And then information about the circuit is on an LCD monitor. And we can see other parts of the circuit in here. There's a resistor, there's an overcharge protection board to protect the batteries. And then over on this side, over there, there's a fuse, a bridge rectifier, which we use to convert from AC to DC current, because we need DC current to use the actual chargers that we have attached to it. And then there's a DC-DC inverter, which again is converting the power to an appropriate voltage for the devices. And there's also a Schottky diode, which keeps the current flowing in a single direction. That's the circuit, and once that's done, it all flows out, and we have some USB chargers that go into things like this cell phone.
Hi, my name's Anna Fada, and I'm the secretary for the UK Energy Club. I'm about to ride this power bike and generate some energy. I'd like to tell you a little bit about our most recent project, last year's hydroelectric tank. The Energy Club e-board started working on the hydroelectric tank project during the summer before the school year began. We had several meetings where we went over several project ideas, and in the end, we went with this one, completely homegrown, made it up ourselves, all the way from scratch. We figured that we wanted something that was easy, but not so easy that our members would be bored, and had enough components that our members would have a fun time putting it together as a hands-on project. And the hydroelectric turbine project is what we came up with. To be very clear, the hydroelectric turbine project does not generate electricity. That would be very cool, but it's a little bit beyond our capabilities as a club to put a hydroelectric turbine that actually generates power inside of a small fish tank. However, this is a demonstration. It's supposed to get people interested in hydroelectric power and renewable energy and show them exactly what it can do. Speaking of showing people what hydroelectric energy can do, let's see it work. Right now, I'm holding our turbine in place because the project isn't quite finished, and it is generating enough electricity to turn on this LED in the middle of our Energy Club sign. Cool, right? Let me describe the components of our hydroelectric tank for you. First of all, we have the tank set up itself. Inside of the tank is an aquarium pump. This aquarium pump is meant to circulate water throughout an entire small koi pond, but we found that the strength was much better suited for this little turbine. This little turbine is the main portion of our project. It generates the electricity that turns on this LED, which sticks out of our handmade sign designed by our fun-loving media director. We also have a handy little lemonade spout attached to the side of the tank so that it can be easily filled and unfilled for ease of transportation. Finally, we have a lid, because when you're messing around with water, it tends to go everywhere. The tank isn't quite done. We do plan on putting a small stand inside the tank and adhering the turbine to the top of the stand. That way it'll be a standalone project and I won't have to hold the turbine in place. Finally, once all of this is done, we plan to install this hydroelectric tank project and another identical unit inside the College of Engineering, the College of Arts and Sciences, or wherever we can get a display case on UK's campus.
So we designed the hydroelectric tank project in the 2019-2020 school year, which was when Anna and I were the project directors for the Energy Club. It presented a lot of unique challenges to us because, as we stated, it was made fully from scratch. So we had an idea, we had a few ideas. We didn't know if they would work though. We thought we could power 4 little turbines. We had some guess as to what kind of power we would need. And we tried to make it work. And we pretty quickly, once we started working on that part of the project found that it didn't really work. We couldn't get enough power. There was no way to get all 4 turbines turning to the degree that we needed. And so we started looking at other ideas. We found a more powerful power head, a fountain head, and we found that we used only 1 turbine, we could make it work with just the 1 light. And once we had that, we were able to, after a few months, longer than we wanted it to take, but we were experimenting, we were figuring it out. There was a lot of work to do. But after a few months, we were finally able to put together a functional tank, which is what we showed you. And then right after that, I believe, was spring break. So we did not come back to school after that, and the project did not get finished. And so now we've been struggling to be able to get people to work on the project because you know, there's limitations on what kind of events we can hold. We can't really have a lot of project work going on right now due to the ongoing events. But we are hoping that we'll get this project finished eventually. We know what we're doing, and it works, and we're really proud of the work we've done on it.
We hope you enjoyed our power bike demonstration and our hydroelectric turbine demonstration. We hope that if you come to UK, you'll consider joining the Energy Club, where we fuel innovation for a brighter tomorrow and spread positive energy. Our hydroelectric turbine demonstration project sponsors were Dynetics and Mr. and Mrs. Pigman, and our UK Energy Club sponsors are LG&E KU, CMTA Energy Solutions, and Harshaw Train. Thank you so much for watching, and we hope to see you for a brighter tomorrow.